Welcome back. This is a topic from water and hydrogen, where we shall determine the redox reaction occurring here. Of course, there will be a reducing agent here, and there will be oxidizing agent between hydrogen and copper 2 oxide. And this is the diagram that we shall use to answer the following two questions. The first one is reading, after the experiment has been running for some time, record the two major observations. I'm going to start with what happens here and the reactants, the reagents inside the combustion tube. We have dry hydrogen being passed through the combustion tube with a porcelain boat containing copper 2 oxide, and on the other side we have copper 2 oxide. Is this really not really? That's copper 2 sulfate solids. This must be copper 2 sulfate, not 2 sulfate solid. That is copper 2 sulfate solid, which is used to test the product that comes after hydrogen reacts with copper 2 oxide. But let's ask what happens when hydrogen comes into contact with copper 2 oxide, of course, when they react. So let's see. We shall have hydrogen gas reacting with copper 2 oxide solid, heated copper 2 oxide, which must be heated. This one we shall heat. And therefore the products we expect here is that hydrogen shall take away the oxygen atom in copper 2 oxide to form water, it's a liquid, leaving behind copper in the porcelain pot. And therefore, our observations are derived from the products that we have obtained. We shall have water and copper as our products, and therefore our major observations are based on the products that we have obtained. The water that we shall have here, it shall come over the other side on the cooler parts of the combustion tube, which should be tilted, of course, and this water here is going to meet or react with copper 2 sulfate, which is an anhydrous. This is dry, white copper 2 sulfate. It's white in color, and we shall leave behind copper alone. Initially it was copper 2 oxide, and therefore in this case our first observation will be based on this porcelain pot, and the other observation will be on the white copper 2 sulfate, which will have a change because of the water that was formed after hydrogen was passed over out copper 2 oxide, which will now, hydrogen is able to act as a reducing agent. It will reduce copper 2 oxide to copper by taking away the oxygen atom that copper 2 oxide has. Therefore, the first major change will therefore be black copper 2 oxide changes to brown. Copper 2 oxide is always black in color. So black copper 2 oxide changes to brown. And the brown color is for copper, the copper that was formed. Copper is brown in color. So that's the first change, the first major change. The second major change will occur at the white copper 2 sulfate. That's one of the chemicals that are used to test, that we normally use to test for water. It's copper 2 oxide, and the other one is an anhydrous copper 2 sulfate. So in this case we have copper 2 sulfate, which is white. Because of the water that's going to be formed after the reaction between hydrogen and copper, the water will now react with copper 2 sulfate, whose color is going to change from white to blue. So therefore that will be our second major observation, is that the white copper 2 anhydrous copper 2 sulfate, anhydrous copper 2 sulfate will change to blue. Will change to blue color. Will change to blue. Anhydrous copper 2 sulfate, white anhydrous copper 2 sulfate will change to blue. That's nice.